the acids, this one had a lot more ions in it. Okay? Now, this gets back to our use of the term electrolyte. Are each of these substances, that is, each of these compounds, HCl and acetic acid, are they both electrolytes? Definition of electrolyte was? Something that dissolves in water and produces ions, right? And these both dissolve in water and produce ions, right? But one of them is a better electrolyte than the other, isn't it? But, here's the thing. When we use the term strong and weak electrolyte, can I have a solution of hydrochloric acid that conducts worse than a solution of acetic acid?
Yes.
Here's the 0.0001 molar HCl solution. Grab the lights for me, would you say?
Sandy.
Sorry. Can you see it? It's conducting, isn't it?
Yes.
But it's got 1/10,000th of a mole per liter. Go ahead and get the lights. Sorry, Sam. Here's a 0.1 molar acetic acid, 10 times more concentrated than this one, and it's bright. So which is the stronger electrolyte, acetic acid or HCl? HCl is. It's not about how much it conducts, it's about what percentage of the molecules when they dissolve end up forming ions. To what extent does a compound produce ions when it dissolves?
Does the relationship between like conductivity and concentration have like a relationship? Is it like direct or is it like, yeah?
And proportional,
Yeah.
pretty much.
Can you repeat that real quick?
So here's the key. Here's the key. We have two electrolytes here, acetic acid and HCl, both dissolved in water, right? This is not an electrolyte. It's a solution of an electrolyte, right? I have an electrolyte dissolved in water in all 6 cases. They're both electrolytes. However, this solution doesn't conduct as well as this solution. So in other words, a dilute solution of a strong electrolyte could conduct less than a concentrated solution of a weak electrolyte. So what is it that determines whether an electrolyte is strong or weak? Not how well it conducts, right? About 1% of the acetic acid molecules, when we make a dilute solution like this, end up producing ions. 99% remain as neutral molecules in solution. That's why this is a fairly weak electrolyte. To what extent do the molecules break up to form ions when we dissolve them? The situation is roughly reversed here. About 99% of the HCl molecules that we put in this solution originally have separated and formed ions. Only about 1% or less remain as neutral molecules. That's what makes this a strong electrolyte, even though a dilute solution of HCl doesn't conduct very well. We okay? Strong and weak electrolytes, but also this equilibrium thing, huh? We say that the equilibrium in this reaction sits primarily towards products. Most of the reactants have reacted to make products. We say the equilibrium here sits mostly towards reactants. Only a small number of the reactants have actually ended up reacting to make products when equilibrium is reached, when we reach that balance. How are we doing? This is our introduction into chemical equilibrium. We deal with it primarily in chapter 18.
So that does mean that strong electrolytes are always strong acids?
No?
No?
Strong acids are strong electrolytes.
So,
But sodium chloride is an electrolyte, isn't it? In fact, every ionic compound is a strong electrolyte because every bit of an ionic compound that dissolves forms ions. Even a compound like lead chloride, for instance, which is not very soluble, every bit that does dissolve separates to form ions.
Wait, you said that the stronger the acid, the stronger the electrolyte? I thought it was
Strong acids are strong electrolytes. Weak acids are weak electrolytes.
But like, say, okay, how about a strong base? That would be a strong electrolyte too, because it has
Then
more
we have to
ions.
start talking, we have to narrow our definition down to what we mean by a base. Right? Because any negative ion can be a base, and we know we put negative ions in solution, it conducts electricity.
But bases get more hydrogen ions though, right? Because, right? So then since electrolytes, the definition
So a
is-
strong base can take on a hydrogen ion, but then does it become a neutral molecule? A base such as the sulfite ion, SO4 minus 2, gains a hydrogen ion to become hydrogen sulfite. Sulfite becomes hydrogen sulfite. It's still an ion, and it still allows the solution to conduct electricity. So talking about this whole thing, talking about strong and weak electrolytes, about bases becomes a little stickier. So we're using it to talk about this idea of strong acids and weak acids. These solutions don't conduct electricity nearly as much as they should, given the concentration of the ions, right? Or concentration of the acid that's there. That's because the equilibrium favors the reactant side. Most of the reactants are still intact, haven't reacted, haven't given up their hydrogen ions. Okay? Okay, now, let's take two bases. Excuse me. Let's write an acid-base reaction and talk about to what extent it's going to form products. Let's try this. This is a little different now. We're not talking about dissolving an acid in water and exchanging